Hi, this is Cam, um, term 3, week 5. A lot of it is repeat this week, so half of it we did from term 2 and term 1. Which of the following symbols refers to the heat content? Heat content, they didn't say change in heat content, that's just H. Which of the following are examples of endothermic processes? This one you have to memorize. Melting an ice cube is breaking bonds, so it's an endothermic. We're heating carbon with water to form hydrogen gas. It's also endothermic. You have to memorize these. And now this question is really annoying. So what you have to do is somehow find a way to cancel everything except C and O to get CO2. So first we're gonna reverse, I'm going to name the reactions. We're going to reverse reaction 3 so we can be able to cancel the H2O. So when we reverse it's going to be H2O, and then it decomposes to H2 and half of O2, and the sign of the delta H is going to change to plus instead of negative. Now we combine all of the reactions, so we put all of the reactions together and all of the products together. So we have 2C plus H2 plus C2H2 plus 5 2O2 plus, now see here, this is the reactant, plus H2O, don't count the last one, just do the first three, and then it gives C2H2 plus 2CO2 plus H2O plus H2 and half of O2. Now let's see what is on both sides so we can cancel it. H2 and H2, H2O and H2O, C2H2 and C2H2. So now we have 2C plus 5 over 2O, 2 plus gives 2CO2 plus half O2. It's basically as if you're solving for X. If you move this to the other side it's going to be minus, but you can't move it, they just cancel. 5 over 2 minus 1 over 2, it gives 4 over 2. So 2C plus 2O2 gives 2CO2. Now we got the reaction that we want. Now to find the heat, we just add this up. So 228 minus 1300 plus 286. You're going to get, you get minus 786 kilojoules. For now we have the reaction and its heat. So again we have the reaction and the heat. Now we want this reaction. We're going to divide this whole thing by 2. So we get C plus O2 equals CO2, and the delta H is now minus 393. Best when they asked for part 1 here they wanted the formation of CO2. And now we have the reaction. So for part 1, which of the following gives the heat formation of CO2? Now remember what we did before, that we added all of this. Yeah, so when we added it we got minus 786. Then remember we divided it by 2 to get only one CO2, so we're going to divide it by 2. So this is how you get part 1. 228 minus 1300 plus 286 over 2. وبعدين part 2 they wanted the heat change for 1 mole of CO2. We got it, delta H is minus minus 393 minus 393. So here they ask for the change in heat content is symbolized by delta H or triangle H. Here they said change. Question 5. Here they're asking for CO2, the heat of the reaction. So heat of the reaction is products minus reactants. So here CO2 is minus 393 minus CO minus 110, and O2 is 0. Well, since it's an element, it's 0, so just don't put it. And it gives minus 283. Here they're talking about delta H. They want us to write the equation including H in whole numbers. So since delta H is negative, it's exothermic, the energy is going to be in the product side. So we write here. And they want whole numbers, and the denominator is 2, so you multiply the whole thing by 2. So you get 2C plus O2, 2CO2. Don't forget to multiply the energy as well, plus 220 kilojoules. Don't forget the unit, small k, capital J. And also don't forget the state elements. So here when they give you bonds, it's the equation is bonds broken, sum of the bonds broken, minus sum of the bonds formed, equals delta H. فهير bonds broken are the reactants, where bonds formed are the products. Okay, they want delta H here. So we're gonna do bonds broken. We have the triple bond between N and N. Here it is 945 kilojoules. So 945 kilojoules plus, because we're still getting the sum of the bonds, we have 3 H bonds, H2, so plus 436 kilojoules. Now we do minus the bonds. We have 2 of the same exact thing, and each one has 3 NH bonds. So 389. So now you have your what you're gonna put in the calculator. You put it in your calculator, and you get minus 81 kilojoules. And for this question, it really depends on how you put it in the calculator. So I recommend that you do the sum of the bonds broken, then the sum of the bonds formed, وبعدين you subtract them. Don't put it all at once, because you might forget a bracket here or there. So how you would do it is 945 plus 3. We have 3H2 for 436. You do this alone, you get 2253. And then you do this alone, so we have 6 NH bonds, 389, and you get 2334. وبعدين after you finish all of that, you do 2253 minus 2334, where you get minus 81. And don't forget 2 significant figures, so minus 81. And then for part B, they want the type of the reaction. Since delta H was negative, it's exothermic. Here you do again products minus reactants. So the products we have 2CO2 and H2O. So 2CO2, we have minus 394 برضو here it's better to do each one alone. So plus H2O, H2O here it's minus 286, minus the reactants O2, since it's an element so 0, so it cancels. Imagine it's not there يعني. We see 2H2 it's 228, so minus 228. Put it in the calculator, you get minus 1302 kilojoules. For significant figures, it's already for significant figures. Here you do RRGR, we're doing RRGR again this week. So CH4, or 1 mole of CH4, it produces minus 819 kilojoules, where here they want it in grams يعني, فyou're going to do the whole thing in grams. So mass is equal to molar mass times moles. Here it's only 1 mole, so it's equal to the molar mass. Molar mass is equal to 1C, so 12, plus 4H, H is 1, so 12 plus 4 equals 16. So 16 grams equals minus 189 minus 819 kilojoules. وبعدين they want it when there are 3.2 grams. It gives X. Cross multiply, so minus 819 times 3.2 divided by 16 equals X. You put it in your calculator, minus 819. You get X equals minus 163.8. And you want 3 significant figures, so you round it, and it's minus 164 kilojoules. The sign of delta H for this reaction is, here you have the reaction, the energy, or the kilojoules, or whatever you want to call it. It's in the product side, so the reaction is exothermic. When it's exo, delta H is negative. And they want the formation for 1 mole of HBr. 1 mole of HBr, here you have 2 and it gives 72, so you divide by 2 and it's 36, minus 36. So here also RRGR. I'm just gonna do with the moles and then convert at the end. So 1 mole of C2 H6 ethane, it gives minus 1560. We want X when it gives minus 390, so minus 390 equals minus 1560 X. Solve for X, minus 390 divided by minus 1560, you get X equals 0.25 moles. وبعدين they want the unit in grams, you convert. To get the mass, it's molar mass times moles. Molar mass here it's 2 C's, so 2 times 12, plus 6H, so 6 times 1, and you get 30. So your molar mass is 30. So to get the mass, you multiply it by the moles. Moles are 0.25 times 30, and you get 7.5 grams. They wanted 3 significant figures, so 7.50 grams. 7.50. They're asking about moles of ions, so you write the dissociation reaction. So Cr NO3 3 in H2O, it gives Cr plus and 3 NO3 minus. وبعدين you basically do RRGR, so 0.5. Here we have 0.5 moles of CrNO33. With 0.5 times 1, you multiply the moles by the coefficient. Here no coefficient, so 1. Coefficient 3 times 0.5. So for Cr plus it's 0.5, and for NO3 minus you get 1.5. Two significant figures. This one is already two significant figures, so you add a 0 here, and now it's two significant figures. Now, so PV equals nRT. We have 0.0440 grams of hydrogen. It gives pressure P at 57 degrees Celsius with 3 liters. R is 0.0800. So we have a lot of converting to do. Volume is already in liters, so you no need to convert. 57 degrees Celsius, we want it to be in Kelvin. So we add 273, 57 plus 273. You get 330 Kelvin. And 0.0440 grams, you want it to be in moles. So N equals M over M. 0.0440. H is 1, since it's gas, so H2 over 2, you get 0.022 moles. So P is 3, V is, sorry, P is X, V is 3, N is 0.022, R is 0.08, where T, sorry, capital T, 330. So now you put it in your calculator, you get, you get 0.1936. They want three significant figures, so you're going to round, so 0.194. They want to find the ionic compound. Again, we did this last term, I think, yeah. You do the crisscross method. Here it is the same exact number but different sign, so it just cancels, so MgO. Also here 1 and 1 opposite sign, so they just cancel, so NH4Cl. وبعدين here these two you do crisscross, so it's Ca3 and N2, where here crisscross Al2 SO4 3. You use the bracket because we want subscript here 3, but there is already 1 after the 4, after the O, so use the bracket so you don't confuse them. C equals N over V. We did this last time also. This question came like every week. So they gave you 0.5 moles over 1 decimeter. So 0.5 molarity, two significant figures, add a trailing 0. But they want the moles, so N equals CV. So C is 0.5, V is 0.1. Put it in your calc. You get 0.005. Two significant figures, add a trailing 0, and it's 0.050. They want the volume now, so you do C equals N over V, and then solve for V. C is 0.2, moles is 0.1 over V. Cross multiply 0.2, V equals 0.1, 0.1 over 0.2 equals V. You get 0.5 decimeter cubed. وبعدين last part, They want it in grams, not moles, so you're going to find moles and then convert to grams. 100 centimeter cubed, you want it to be decimeters, so you're going to divide by 1000, and it is 0.1, لا 0.01. لا 0.1 sorry, so 0.1 decimeter cubed. 0.1 times the molarity, N equals CV. We want the volume, we got it, so 0.1, and then 0.1 m, so 0.1 again, so you get 0.01. moles. وبعدين you want sodium carbonate, so NaCO3. You get the molar mass. At this point I'm not gonna show you how to get it. Have some independence. So 23 plus C, 48 you get. So we got the mole 0.01. It's Na2CO3, my mistake, sorry. Again, you're going to find it 46 plus 12 plus 48. You get 106 times 0.01, and you get 1.06. 3 significant figures. It's already 3 significant figures, and that's it. Now you want to find which one is the heavier gas. So whichever one has a smaller rate of diffusion, it's the heavier gas. Hydrogen chloride has 0.87. Gas X has 0.63. So which one has less? I don't know, you tell me. So 0.63. So gas X. And find the molar mass. You get rate of diffusion 1 over rate of diffusion 2 equals square root or radical molar mass 2 over molar mass 1. Molar mass of hydrogen chloride is 36.5. So R1 is we're gonna do R1 is gas X, so 0.63. R2 is hydrogen chloride, so 0.87 equals radical M2. So we have 2 is our hydrogen chloride, so 36.5 over X, cross multiply 0.63 radical X equals 0.87 radical 36.5. solve for X, radical X equals 0.87 radical 36.5 over 0.63. You put it in your calculator and then square it. You get X equals 69.606 approximately يعني, and you want to be 3 significant figures, so X equals 69.6. last the one before the part 2 يعني, in increasing order of rate of diffusion. So the more it goes, the lighter it gets. CO2, C is 12 plus 32, it's 44. HCl, we already got it, 36.5. H2O, at this point, don't be stupid, know it by now, it's 18. Which one is the heaviest? Put it in the beginning, then 36.5 وبعدين 18. Shocking, I know, it's so hard. Anyways, part 3, last one. They want the lighter gas. Sorry. First, they want uh, the process in which they react or why they react. Gases are always moving in random, so it's called diffusion, and they react here. Now we want the lighter gas. Which gas travels further or more space because your simple brain? So it is this part. They reacted here, so this one moved more than this one. Use your eyes. I know. If you're blind, you wouldn't know, but you can clearly see it. So term 1, beginning of the year. Remember when it was so easy, so simple? Now it's whatever this is. So crystallization is a separation technique used to extract substances from a mixture. Choose the type of a substance that can be extracted from a mixture or with water using crystallization. So crystallization, you have a solid dissolved in a liquid. You're not going to use crystallization for sand and water. Use your brain. You would use filtration for that. So crystallization is going to dissolve it, so it's soluble. بعدين part 2 B. Select the apparatus needed for crystallization. Memorize it. Bunsen burner, evaporation dish, wire gauze, and beaker. Why would you need a mortar and pestle? Or a separating tunnel? Or a conical flask? Are you going to prepare a solution in it? Thermometer, you don't really need it either, so it's just Bunsen burner, evaporating dish, wire gauze, and beaker. And then part C. Which of the following steps are part of the crystallization process? Boil the mixture over a Bunsen burner till all of the water evaporates. No, you want it to have some water in it. Heat the mixture aside until the crystals settle at the bottom of the beaker. You're not going to heat it. So wrong. Warm the mixture over a steam bath. Yes. Leave the solution overnight. Yes. Till all of the solvent dissolves. Then heat the solution till most of the liquid evaporates. Yes. Not all of it, most of it. Filtrate. Who brought filtrating into this? It's not invited, so immediately wrong. Chapter 5. We just did this for physics, so I'd be surprised if you don't know it by now. So P1V1 over P2V2 equals T1 over T2. NR and NR, they cancel, so you don't need them. They're useless. So P1, it's 50 times V1 is 6. P2 is 100 and V2 it's X. T1 it's 177 converted to Kelvin. You get 450 Kelvin. بعدين 627 convert to Kelvin. You get 900. So 450 over 900. Cross multiply to solve for X. So 45000 equals 300 times 900, and solve for X. You don't really need me for this, so you get X equals 6. RRGR. So fun, I know. So we wanted to have 0.5 mole of butane. Butane is, which one of these don't you know? C4H10. So this one is going to be butane. Don't ask which one is butane. This one is oxygen. This one is carbon dioxide. This one is water. Which one is left? C4H10. So it's butane. So we have to and we need 13 oxygen for it. We have 0.5 and x cross multiply. 13 times 0.5 equals 2x. Do it in your calculator or solve for x. You got 13 over 4 or 3.25. 3 significant figures. It's already 3 significant figures. You don't need to do anything else for it. Now we want to find the volume of oxygen gas to 0.5 mole of butane gas. We got it in part A, the moles. So to get the volume, so V equals N times V gas, or molar volume. Here it is in RTP conditions, so it's 24 decimeter cubed per mole. So 3.25 times 24, you get 78. Yes, 78. 3 significant figures, add a trailing 0, and that's it. Now air is 20% oxygen gas. They want the volume of air needed for the sample of butane gas. Here they're talking about the 0.5 moles of butane gas. Now 5 VO2 equals V air. Air is 20% oxygen. So how many 20% do you need to get 100%? 5. I don't know what level grade math is this. I think it's grade 4 by now. So use your brain for a bit. VO2 is 78 times 5 equals 390 decimeters cubed. 3 significant figures. It's already 3 significant figures. Hydrogen gas combines with oxygen gas to form water. The reaction involves an energy change of 284 kilojoules per mole of hydrogen gas. The energy diagram of the reaction is shown down below. So energy diagram, when it's going down, it's exothermic, going up endo. So it's exothermic. When 1 mole of water is produced, 284 kilojoules of energy is released. We already said it's exothermic. It's not going to be absorbed. So released. What is the amount of energy involved when 0.5 moles of hydrogen gas are consumed? This one is per mole of hydrogen gas. We wanted 0.5 moles, so just multiply this one by 0.5. 284 times 0.5, you get 142. 3 significant figures is already 3. Now you have, in an exothermic reaction, energy is, you fill in the blanks. Released. Good job. Therefore, the temperature of the reaction, it increases. In an endothermic, it's absorbed. Burning, they said burning. They literally gave you the answer, burning. Energy released. It gives flames. Exothermic. Water solidifying. Solid. Liquid. Gas. Exo. Endo. It forms bond, so it's exothermic. Dissolving sodium hydroxide in water, which makes the solution warmer. It makes it warmer. Exothermic. Melting. Breaks bonds. Endothermic. Melting from solid to liquid. This way. Endo. A sample of O2 gas contains 9.0 times 10 to the power of 21 molecules. Avogadro's number is 6 times 10 to the power of 23. How many moles of O2 does this sample contain? Now to find moles from molecules, it's moles over Avogadro's number. 9.0 times 10 times 10 to the power of 1 over 6.00 times 10 to the power of 23. You get 1.5 times 10 to the power of negative 2. How many grams of O2 to get the grams mass equals molar mass times moles? Molar mass here, they gave you O2, O alone is 16, so multiply by 2, molar mass is 32. 1.5 times 10 to the power of minus 2 times 32, you get 0.48. Here it's supposed to be scientific notation, but they also accept it. So just 0.48 grams. Two significant figures. We want the number of moles in the sample. It is 17.6 grams of propane. So we want moles. First we find molar mass. You find it out. 48 plus 8. Sorry, not 48. 36. 12 times 3 plus 8. It is 44. So 17.6 moles is mass over mass. So 17.6 over 44. 17.6 divided by 44. You get 0.4. 3 significant figures, add 2 trailing zeros, and mabruk, you got the answer. Part 2. How many atoms? To get the atoms, you do atoms equals moles times Avogadro's number times atomicity. Now, if you somehow forgot what atomicity is, it's the number of atoms in the molecule. So we have 3 C atoms and 8 H atoms. They add up to 11 atoms. So 0.4 times 6.02 times 10 to the power of 23 times 11. And you get 0.4 times 6.02 times 10 to the power of 23 times 11. You get 2.6488 times 10 to the power of 24. They want 3 significant figures. So 2.64, you round it, so 2.65 times 10 to the power of 24. They accept 2.64 times and 2.65. I don't know why they should put 2.64 is wrong, as it should be 0.65. They accept both anyways. Finally, last question. So we have this reaction. We check if it's balanced. We have 1 ZN, 2 H's and 2 Cl's. It's balanced. We want the number of zinc moles consumed in the reaction. So we have 0.109 grams of zinc. Zinc is a metal, so it's just 65.4. So it's 65.4. To find the moles, N over M over M, N equals M over M, equals 0.109 over 65.4. Put this in your calculator. You get 1.67 times 10 to the power of minus 3. They want 3 significant figures. It's already 3 significant figures, so part A done. Part B. They want the number of moles of hydrogen gas. So Zn and gives H2. We already had 1.67 times 10 to the power of minus 3 moles of Zn, and first we had in the RR 1 and 1, and we want x, so x equals 1.67 times 10 to the power of minus 3, cross multiply. That's part B done. Now they want the volume of the hydrogen released at RTP conditions. Since at RTP conditions it's 24, so you multiply this by 24. You get 1 over 25, or 0.04 decimeter cubed. They want it in centimeter cubed, so you're going to multiply by 1000, and it gives 40 centimeter cubed. Now you're going to look at the syringe and see which one is 40. This one. Such amazing observations. Now we're done with the quiz. Good luck.